the next thing that you need to write down is the perpendicular bisector theorem. Okay, so I'll read this to you. You might have it in front of you. Okay, so you should write, if a point is on the perpendicular bisector of a segment, then...
Please rewrite that one down.
I would definitely write that down. The theorem that's in the box. Pretty good? Mm-hmm. Okay, so the next part of these notes kind of go through proving the perpendicular bisector theorem. So I'm not going to go through all of it. I'm going to basically come to the point where we're going to use it. Okay, and I think that just by using it, you should be fine. Okay, all right, so we have this, this shape, okay, and it says that BD is the perpendicular bisector of AC. Okay, so 4 says if we let ED equal 16, ED, so that's this length right here, that height, and DA is 20, DA over here is 20, find DC. What would that length be over there? 20. Everybody agree with 20?
Yeah.
And why is it 20? Yeah, it's just the same as DA, right? And that's true just through the reflective property, just so you know. So DC would equal 20. Okay, number 5. Okay, that one says that this time EC is going to be 15. I'll write this in red this time. BA is 25. So what is BC? 25. Oh, okay. Too easy. Okay, let's make it harder. Okay, so the next part of this is using the perpendicular bisector theorem to kind of make statements about right triangles. Okay, so I am hoping that this little piece of information looks familiar to you. Anybody heard of the Pythagorean Theorem?
No. Wow, sorry.
Okay, so if you haven't, you need to write this down, and maybe you might need to come see me with questions about it. But it is directly related to a right triangle. Okay, so you must have a right angle somewhere. So it says that a squared plus b squared is equal to c squared, and can somebody tell me very specific pieces about the a and the b and the c?
The C is always the hypotenuse.
Okay, so the a and the b are not the hypotenuse.
It's the first legs.
The legs, okay? And they're interchangeable, right? Okay, perfect. So now that we know that, we could go through a proof of all that if you wanted to. If you have spare time, you can go through there. But let's do this little example here. Okay, so this one says that AD is 10. So from A to D, this is 10. And from B to D, that is a distance of 6. So they're asking us to find the length of AC. So what would I do in order to figure this out?
What do you do? Well, the other one equals 10. 6 squared. No, 10 squared divided by 4 minus b squared. Or 8 squared. Or whatever 6 is.
I heard a lot of whatevers. Okay, so let's try that again. Tell me what you want.
10.
10?
Squared
Okay.
minus 6 squared equals plus.
Okay, I'm not disagreeing with you, but I'm going to write this differently. So what you're doing is fine. So Saray is basically deciding that, okay, we've got this right triangle, right? That's where your brain is headed, I do believe. And so we're going to find this AB distance, and I'm going to label that AB distance x. Okay, so we can use Pythagorean's theorem and say that x squared plus 6 squared is equal to 10 squared. Okay, so if you were going to solve this equation for x, what would you do first?
You're gonna just 36 square.
Okay, square them, right? So going slowly, 100 is equal to 36 plus x squared. Then what would you do?
Let's subtract.
I mean, yes, sorry. What? Oh,
When you subtract 36 from square root.
you're way ahead of me all this. Okay. Sorry. Too slow. So, now what?
Square root 8.
Okay. So if the length of x is 8, what is the length of A to C?
16.
16. Good. So A to C will be double that and be 16. Everybody follow that logic?
Yeah.
Pretty simple. Do I need to do another example with that idea? Okay.
Oh my gosh.
Let's see. This goes through a proof. We're gonna not talk about that. Ooh, okay, so let's talk about this. So this is our last example. So this is giving us that B and D are parallel. Okay, so you see those are the two horizontal lines. And then that E and C are also parallel. Those are the more diagonal ones. That angle M, or excuse me, not angle M, angle 1 is 50 degrees, so this angle up here. 5 is 90 degrees. And we are going to find angle 4. Okay, what would you say angle 4 is? Ooh, 45?
Yeah,
Well, that's equal to 90.
40.
40.
Okay, so let's find some congruent angles. Okay, can we agree that angle 1 is the same as
Angle 2.
angle 2? Okay, so do you see how angle 1 is the same as angle 2? Those two are equal or congruent, okay? So if this is 50, can we figure out what angle 6 is? How would we figure that out? No, how would we figure that out?
What?
Okay.
Hold up.
Okay, so if this is right, then this has to be right too. So angle 2 and 6 have to equal 90, right? Because it's a perpendicular line. So 90 minus 50 makes 40. So angle 6 is 40 degrees. And so therefore angle 4 is a vertical angle from 6. So therefore measure angle 4 is 40 degrees. Did everybody follow that logic behind that? Not just go straight to the jumping point?
No, I know.
You're good?
Yes. Okay, so
Oh.
How do we prove
2
that
angle.
How do we know that angle 1 and angle 2 are the same? No, I think that's a good question. How do we know that angle 1 and angle 2 are the same? We don't? We just make it,
You just measure.
we just thought it might be?
Yes.
You just guessed. Okay, I disagree with the guess. I don't like a guess. How do we know? Go ahead.
It says, at the beginning, given that B and D are parallel.
Okay, exactly. So basically, we can use the idea of corresponding angles because those lines are parallel. And since line A is a transversal that is cut through there, we know that 1 and 2 are corresponding angles. So corresponding angles are then congruent.
Okay, so then
Okay.
what are the relationships between 2 and 6? What are they?
So 2 and 6 are 90 degrees. Okay, and the reason why we can say that is because if we have this line right here, cut right through this line, and this is a 90-degree angle, then this side has to be 90 degrees as well, right? They're supplementary, straight line supplementary. We could also say that all three of these angles would equal 180 degrees, right? Because it's a straight line. Linear pairs, well, linear triples in this case. Okay, so you know that these two have to equal 90, so 50 plus 40 is equal to 90.
Okay.
So 6 is 40, and then you can say that 6 and 4 are vertical angles, and so therefore congruent, so that it would equal 40. Okay. How do you guys feel about this? Pretty easy stuff?
Yeah.
I think that's as far as I'm going to go. Okay, so that should give you